All right, so first of all, once again, we're going to be talking about vectors and scalars. So what is a vector and what is a scalar? How many of you have seen the movie Despicable Me? Okay, then you know what a vector is. Okay, somebody said what? Over here? A person. Well, it's a person, yes, but in the movie, the guy named Vector introduces himself because what does he say exactly? He commits crimes of both, or with both. It's been too long. Okay. Anyways, all right. So vectors. We're first going to put a definition here, and then we're going to have kind of like all of the different examples that you're going to have for vectors. So a vector is something that has both magnitude and direction. So if you remember from the movie, he said, "I commit crimes with both magnitude and direction," and then he goes, "Oh yeah, right." No. All right. So vectors have a magnitude and direction. So what's a magnitude? Is that the next question that was coming to mind? Anybody? What is a magnitude? I know you've heard the term before. What is a magnitude? Would you say that 50 pounds is a magnitude? You're nodding yes. Why? You were just moving your head. We're going to take this or not. Okay. So Dan says yes, 50 pounds is a magnitude. Dan's correct, which is why I went with it. Okay. So magnitude you can think of is, and if you want to jot this down in your notes, a magnitude is a number, a value, a quantity, an amount. So it's like how much you actually have. Magnitude is how much. Okay? So you could have a magnitude of the temperature. What is the temperature supposed to be outside today? Anyone know? 50-something degrees, right? So in the 50s would be the temperature. And so that would be the magnitude. So let's say the magnitude of the temperature was going to be 55 degrees Fahrenheit today. Well, that's my magnitude. Do I have a direction for that? Would I say what direction the temperature is pointing? No. They don't address, they're like, oh, it's 55 degrees Fahrenheit north. You don't hear that. You don't want to hear a direction with that because that's actually going to be a scalar. And so a scalar would be like temperature. So what am I going to write for scalar? Yes, exactly. Good. So scalars have magnitude, but no direction. Which tells me that right now, in terms of physics, you guys are scalars. You have all this knowledge, but you have no direction to go with it. Okay? Pretty soon, you guys will be vectors then, right? So you're going to have all this knowledge, and you're going to have a direction that you're traveling in. You're going to know exactly where you're going to go, so by the end of this course, you know that you're going to be a physics major once you get to college. Right? Totally. Okay? So that is the direction that you would be traveling in. But if I'm looking at vectors as opposed to scalars, can you guys give me some examples of vectors and scalars? So something that has only a magnitude, or something that has only, or has a magnitude and also direction. So any ideas? I kind of gave you one example. Temperature would go where? It would be a scalar. Good. So you could add temperature on this side. What else could I have? We will be discussing two of them today. One's going to go on this side, one's going to go on that side. So if you looked at, the back board, it would tell you exactly what we're going to be working on today. So what is it? What are we talking about today? It's Wednesday. So what? Distance and displacement. Yes, good. So we have distance and displacement. And what is a distance? Would you say it's a vector or a scalar? So if I was talking about distance, I would say that as I'm walking through the room, I am going to travel a distance of 10 meters. Okay? So I walked up down the aisle, all the way around, and I ended up over here. Did I have a specific direction that I was traveling the whole time? No. I changed my direction. But I measured that the total length there was 10 meters, which means that that is a scalar. So distance is just a scalar, because it's only going to tell you how far you are actually traveling. It's not going to tell you in what direction you're traveling. So that means if distance is the scalar, what am I going to write over here? Displacement. So displacement is a vector, and we're going to look at the definition a little bit later. So displacement must include a direction, so that's going to tell you how far and in what direction you're traveling. We'll explain how you can actually create the displacement, and that's kind of what your homework's going to be like tonight. Okay? Other things, if you look at tomorrow's discussion, there are 3 things listed there. You have speed, you have velocity, and you have acceleration. Okay? So where is speed, velocity, and acceleration going to fit in here? Ideas? Speed is what? Speed is a scalar. Very good. Speed, more or less, is just going to tell you how fast you're traveling. So you could look at the speedometer in your car, and it's going to say that you are traveling 22 miles per hour. It does not tell you which direction you're traveling. You would have to look at a compass in your car, or if you had that compass like piece on your rearview mirror, then you'd be able to know exactly what direction you're traveling as well. So you could technically create what is your velocity, which will be a vector. And so your velocity would have both a magnitude and a direction. You'd know how fast and in what direction you're traveling for velocity. You notice that they kind of like connect together. Distance and displacement go together, and then speed and velocity go together. Okay, acceleration is the last one. We're actually going to add that under the vectors section, because that also requires the direction. And acceleration can be both positive and negative, and that is one indication to let you know that it could be a vector. All right, shall we add just like 1 or 2 more to each side? All right, so what's another example that we could use for scalars? Something that does not require a direction. Something that you could measure for a quantity, but you don't need to know what direction. I will give you a hint. You did this in your lab. Actually, 2 measurements in your lab. What's that? Not weight, but what did you measure? You measured mass. Right. So mass is an example of a scalar. Weight, we will actually see, is going to be a vector, but we'll put it in as something different on this side instead. So mass is a scalar. What's something else you guys measured in your lab? Volume, and volume does not require a direction as well, so you could put in volume. We could also throw area in here. Those are all examples that don't require a direction, that's just an amount. And so you would read that amount, you'd say, 30 meters squared, that's an area. And it's not going to change. There's no direction to it. It's just how much you have. Okay? Another one, the last one that we could use is time. Time is like an important scalar quantity because naturally you don't have a direction to time. You're just measuring or counting how much. Okay? Other vectors. One that we're going to get into in Chapter 5 is going to be a force. And so force, an example would be weight. So Lexi said that weight would be a scalar, and so she's thinking more of the mass. So weight is actually a type of force. It is in a specific direction. What direction would weight point? Downward, exactly. So we do have a direction to it. If you made down negative, then you'd make your weight negative. Make sense? So we usually think of our weight as we just step on a scale, we look at the number, and it tells us what it is. What it's actually reading is pushing up on your body, which will be a force that we'll talk about in Chapter 5. Let's see anything else that we're going to add in here. We'll throw a couple more in since we have a lot on the other side. Let's add in momentum. Momentum is something that we're going to talk about this year, and it is also a scalar because it is going to be found by multiplying a scalar, it's also a vector. It's going to be found by multiplying a scalar times a vector. It's actually mass times velocity, which we'll discuss in Chapter 9. Okay. So this is just a brief introduction because actually what we're going to see in Chapter 3 is going to be this, and we're going to do a little bit more with it because we're going to get into our trigonometry discussion in Chapter 3. All right, so a couple more definitions. So when we're looking at this one, we can see the definition is for displacement. And so I can see that displacement refers to a change in position. And so the change in is this symbol that you see down here. So I'll give you a chance to write that down. You will notice that if you looked at the back of your equation sheet, you're not going to find this equation on there. I used to put it on there, but it would really confuse people. They would start to use it as soon as they knew they were looking for displacement. They would go right and try and use this equation and punch two numbers in for x final and x initial. Really what happens here is a lot of times your x initial, this is typically 0. And the reason it's usually 0 is because a lot of times you want to pick the spot where you're starting to be 0. So your delta x is really going to be just the total displacement that you travel, because it's going to be a straight line from start to finish, which is what we're going to look at in a little bit. Okay? So delta x, anytime you see this delta symbol, what does delta mean? Change in. It means change in. So anytime I see a delta, it does not mean distance or displacement, but it means change in. And this happens every semester. You guys are going to eventually get a couple other equations where you're going to have this delta symbol, and you're going to think, oh, that's distance, and I'm going to throw anything that I see as a distance in for delta. But delta is just something that is going to split your quantity into final minus initial. Another example, if I was to say that I have delta smiley face, what is delta smiley face going to give me? What is that equal to? Delta x is x final minus x initial. So delta smiley face is smiley face final minus smiley face initial. So it doesn't matter what follows the delta symbol, it's always just going to make a final minus initial of whatever that quantity is. So your book might use different notation than what I'm going to use up here. So if you actually did take a book out, so for those few of you who did take a book out, you might see instead of an F, you'll see nothing there as a subscript. And instead of an I, you'll see a little circle, which means not. And a not typically means your initial or your starting value. So x final minus x initial, smiley face final minus smiley face initial, it all means about the same thing. It's just delta is changing. Got that? I'm like trying to overemphasize it so you don't run into that problem of plugging in a distance or displacement every time you see a delta. Okay, so your displacement you can find by just taking your final minus your initial. That's great if you're in a straight line. If you're not in a straight line, which you're going to see a little bit later, things will change. All right, so if I'm looking at this situation and this gecko was to travel from 38 centimeters all the way out to 88 centimeters, I guess technically the tail would have to be right there to start. Okay, so if I was going from 38 to 88, then what is the total displacement of the gecko? Louder? 50 centimeters. Good. That was easy, right? Okay, so let's take it back. I'll actually start it so I can stop where it is. All right, your second question, what would be the gecko's displacement if we changed the frame of reference so that 0 corresponded to the gecko's initial position? So what I mean is instead it's actually going to start at 0. And by doing so, now what would be the displacement if it traveled on the screen the same distance? 88 centimeters. Good. So what do you notice? What did I change? The what? The frame of reference, exactly. The frame of reference, if I was to move and shift this back, that means that 0 is off the screen to the right. So my frame of reference was all the way to the right, but then instead I scrunched it, so now that it's a little bit smaller, and so now I can actually visually see my whole scale. You know what I mean? So it's like I just stretched or thinned it out. So if I was starting instead all the way back at 0, reaching 88, that's 88 for your displacement, and if you were starting at 38 and reaching 88, that was only 50. You guys are like, well, yeah, that makes sense. And you're like, all right, move on. But this is important because then if I'm looking at this and I'm saying that I'm going to choose 0 to be the edge or I'm going to choose 0 somewhere else, this is just telling me that I don't actually have to start at 0. I could start at a value that is not 0. That was the point of this slide. Make sense? Okay. All right, there is a difference then between distance and displacement. You can kind of write both of these down, and then you can answer your question here, which I answered kind of for you. So what distance will actually tell you, what displacement actually tells you, and then deciding whether or not one or both could be negative. So ultimately what those two questions are saying, the first question there, that would be a question that I would ask you in one of your word problems. So I would be saying, what was the car's displacement? Or I might say, what is the magnitude and direction of the car's movement or position change or something like that? So as I'm looking at any of those questions, it's got to be talking about either a magnitude and a direction, or it's got to have the word displacement in it. Because anytime you see displacement, you should immediately think, displacement's a vector. If I'm looking for distance, then I would just simply be asking you how far did the car travel? Or what was the total length of the path of the car? Something like that where I'm only asking about a magnitude and not the direction. And to answer your question at the bottom, I think most of you are probably at the bottom now. Yeah? Okay. The bottom question is asking, can they ever be negative? Well, if I have a positive or a negative sign, what does that tell me? Would that be a magnitude or would it be a direction? What do you guys think? If I said that you're traveling in the positive direction as opposed to the negative direction, that would include a way that you are traveling. So it's a particular path that you are going to be headed towards. If I said, please walk 5 meters, you guys don't know where I told you to walk. You could be walking, I could have said walk 5 meters, but I wanted you to go straight through the window. Why would I do that? That's weird, right? But if I just said, please walk 5 meters, and then you walk 5 meters down the middle of the room, that makes more sense. If I said, please walk 5 meters north, then you would have to have a compass, and you'd be walking about yay direction. Okay? If I said, please walk 5 meters south, you'd be heading back this direction, so you might have to walk over top of some desks or something, otherwise they might be in your way. So when they're looking at a positive or negative sign, that means that you're talking about something that is a vector. So displacement needs a magnitude and a direction, and you can add in here because it's a vector. So because it's a vector, it requires a direction as well, which means that a negative sign you're only going to see on a vector quantity. If you saw a negative sign on something, then you know it's a vector. It has to be. All right, and so for this chapter, we're going to be going very basic. You're going to see this again in chapter 3, but all I want to do right now is just to make sure that you guys actually know your cardinal directions. How many of you know your cardinal directions? Okay, good. So what is this?
North.
What is this?
East.
What is this?
West.
And?
South.
Okay. For this chapter, we're not going to make it too complicated. If you are anywhere in this region, we're going to say that you are traveling what?
Northeast.
Okay. That actually, we are going to recorrect that and adjust it a little bit more once we get to chapter 3, because I'm going to kind of focus it a little bit more for you. And then in here,
Southeast.
and here,
West.
and down here.
Southwest.
Okay. So you guys got those, right? Make sure that if you forget them, immediately if you grab like a test or a lab or a homework or anything, just put that on there real quick. That way you don't get confused. How many mix up your west and your east a lot? Anybody? Okay. Well, good. Okay, so here's your first question then. So if I decided to walk a few city blocks while visiting a city, imagine that, if all the blocks are the same dimensions, what would be the distance and displacement if I first walked 3 blocks north, then walked 8 blocks east, then 1 block north, and finally 3 blocks west? How would you do this? How would you do this? Leave a little space. How would you find the distance? Yeah, Maria. Your what? Yeah, sure. Where would be a good place to start? 0, 0, somewhere like that. So I'm just going to start on the far left-hand side. Okay? Just because I see they're all going to head in that direction for the most part, aside from the west is going to be coming back. So that way I know that if I'm starting over here, I'm not going to go off the grid. All right, so I'm first going to be traveling, what? 3 blocks north. Let's draw it out. 1, 2, 3. Okay, then what? 8 blocks east, okay? Then what? Okay, this is easy. And lastly, 3 blocks west. Okay, That's not bad, right? Now what? Where would my displacement be? Displacement is going to be, and we'll put a definition on here for you. So displacement is going to be a straight line from start to finish. Very basic, very general definition. So displacement will be a straight line from start to finish. I don't care about what happened in between. All I'm worried about is where I started and where I ended. So where would I draw a displacement vector here? From where we started to the end of the light green vector, right? Okay, so I'm going to draw from here and all the way through my blocks. And that is my displacement. But how long is that? We don't know. Can we find it is the question. Okay, so let's first start out with distance. How would I find the distance? Distance is the length of your path, right? How far you went. So how would I do the distance? Add everything up. So I started out with 3. Doesn't matter about direction. With distance, it's a scalar. And then I'm going to add 8. And then I'm going to add. And then I'm going to add. And I'm going to get 15 what? Cool. Distance is easy. You just add up all of your legs of your journey, and it doesn't matter the direction they travel. They're all positives because it's a scalar. Okay? Displacement, on the other hand. How am I going to do this? How am I going to do displacement? Well, ultimately, I'm traveling from here up to here, right? And from here over to here. How can I find those two measurements? So I need to find this. And I need to know this. How can I find that? In the x direction, I have 2 vectors, right? I have one going how far? 8, and I have another going 3. And so if I have a positive 8 but a negative 3, that gives me 5.
Wait, where'd the...
Okay.
What just happened? I'm sorry.
It's all good. So I'm traveling in just the x direction. X direction. Okay. I'm traveling all the way over,
Okay, I get you.
but then I'm coming back 3 of them. So really, ultimately, from the very beginning, I only traveled over 5. So you can find that, and so I'd say that this is 5. And how about this guy? What do we got? I went up. Up how much? Up 3 here. But then I went up again 1, which is a total of 4. Very good. Okay. What does that make? Oh my gosh. Right triangle. And how do you find the hypotenuse of that right triangle? Yes, you guys are saying either the name or you are saying what it actually is. So a squared plus b squared equals c squared, also known as
Pythagorean theorem.
your Pythagorean theorem. Yes, good. And so if I plugged in a and b, does it matter which one's a or b? It does not. Okay, so I'm going to have 4 squared plus 5 squared, just because I feel like going in that order so that it's increasing order, equals c squared. What's 4 squared? What's 5 squared? Which add them together and you get 41. And so C, and we'll just leave it as the square root of 41, unless you want to find what it actually is value-wise, and what would you get? Square root of 41 should be somewhere between 6 and 7.
6.4.
Okay. And once again, it is blocks. In chapter 3, we will go a step further. And we will actually find an angle theta. But for our purposes here, remember, displacement also requires a direction. So what direction would you say that is? Northeast, yeah, because that's all we're going to do here. So we'll actually adjust this. We'll add that in. So 6.4 blocks northeast. Is that easy?
Yeah.
Okay, so ultimately all we're going to be doing in this chapter, we're going to be looking at distance displacement, at least for today, and combining whether or not you're adding it up to create a distance or finding a start to finish for displacement. Okay, so now let's try it a little bit more. Just a couple examples because this is going to be visually what your homework might look like. All right, so first we're going to draw some lines across from C to A and from B to D. All right, from C to A, what do you think it's going to be distance-wise? If that's 16 and that's 23, what do you think it should be, roughly? From C directly to A, if that's 23 and this is 16, that means that this is going to be something. So that's 39, but it's probably going to be less than 39. But greater than 23, how about 30? It's a nice round number, right? So we'll say that this is 30 miles. And we'll say that one is about, we'll make it 21 miles. Okay. You ready? Looks pretty close to the 21. It's actually, might even be 20. Could be less. We're good. Okay. So if I was to ask you, and this is what's going to happen with your homework. Your homework, you can see that on your paper, you have a map of Africa. And so what we're going to be doing is we're going to be traveling from different cities in Africa. But before we get there, I just want to kind of go through this to make sure you have the idea of how we're going to do that. Okay. So if I was to say, what is your distance and displacement from... And I would give you a couple situations or scenarios. So we're going to say from B to D to A. My question is, what is your distance and displacement from B to D to A? See if you guys can figure it out. Get it? Both of them? Okay. So, first of all, you're going from B to D to A, right? So we're going to go from here to here, which is how much? And then from D to A, which is how much? Which is a total of what for your distance? 43. Okay, so my distance would be 43 miles. Do not forget units. Okay. Your displacement, however, is a straight line from start to finish. So going from B to D to A, where am I starting? And where am I ending? So I want a straight line from start to finish with a direction, and so my displacement would be what? Nice. Very good. Don't forget your direction whenever you're dealing with your displacement. Can you guys do this? Not bad? Let's try one more on this slide, and then we'll move to creating your homework. All right, this time we're going to go from C to D to B to A to C. Yes, it is. All right, let's give it a whirl. So from C to D, how far we traveled? Okay. Then from D to B, how far we traveled? 42 so far, right? And an additional 21. We are now from C to D, D to B, B to A. So we're at 65 because 42 and 23, 65. And then from A back to C would be how much? 95. Good. So my distance this time, 95 miles. My displacement is what? I'm starting at? I'm ending at? Where'd I go? Nowhere. Good. So my displacement is 0 miles. Do I need a direction if I'm not going anywhere? No. Okay. So ultimately, if you guys were, say, born in a specific hospital, and then throughout your life, the maternity ward there then became hospice care. So at the end of your life, you actually died in the same exact room, in the same exact bed. You went nowhere in life. It's terrible, right? Yeah. But physically speaking, I mean, technically the Earth would probably be in a different location. So if you're looking at the frame of reference from a different aspect, then naturally we have actually gravitated away from the center of the universe, and you did travel somewhere. But if your frame of reference was that hospital, you actually went nowhere. Crazy, huh? All right. So, to your homework. Go ahead and take your homework out. I know that some of you are going to be particular, so if you would like lines to be straight. The homework? Check your folder. I probably put it in there. Okay, take a ruler, pass them down. Yes, they are flexible. Yes, you can put them over your eyes. You can look through them like orange glasses. Okay, and they also fold completely around your head. Yeah, that's great. All right. Then you look like somebody from Star Trek. Anyways, we are going to pick 5 locations, okay? Based on a scale, I'll estimate distances, and we're going to keep them in kilometers so that we don't have really, really massive numbers, okay? So, what is one of the locations that you would like to start from?
Zambia.
Chad, okay. So, Chad right in the middle, I'm going to label that a C, okay? For Chad. So you can't pick anywhere else that starts with a C. Does that make sense? I want different letters. What's that?
Are we starting with the capital?
We're going to start different places, and I'm going to give you different things for them.
Let's go to Zambia.
Zambia, okay. So that'll be naturally a Z. What else? Madagascar, okay. Pick a one that has a vowel. Egypt. All right, you guys are being all crunched on a side here. But it's what you guys are choosing, and somewhere over from, that'd be East Africa. Can't use another M. How about Guinea? Is that all right?
Oh yeah.
Guinea. You guys see Guinea? And I'm putting my dots right on the capitals. If you haven't noticed, it just makes it easier. So that's going to be a G. All right, what I'd like you guys to do now is connect all the dots. So each dot is going to have how many lines coming through it? Or coming to it, not through it. Should be 4 lines coming to each one, in or out of it. Make sense? So go ahead and draw your lines. Like I'm going to draw G over to E, G over to C, G to D, and G to M. Okay. Remember, you're getting recorded. All right, cool. And I will wait for you guys now. Shouldn't have used blue. There's too much blue on there. Hold on. Much better. All right. While you guys are still writing, I'm going to start filling in distances. So I'm just going to kind of create some distances based on lengths of these that I see. And we'll go from there. So I'm going to get a rough start so I know roughly where these distances will be. Yes. All right, so here are my distances. Going from Chad to Egypt is going to be 6,000 kilometers. That'll be my scale, makes it easy. So we'll say going from Guinea to Egypt across the top will make this 14,000 kilometers. And naturally, I'm going to try and make them all nice and easy for you guys. And going from Guinea to Zambia, make it about the same. 14,000 kilometers. Across from Guinea all the way to Madagascar is going to be 18,000 kilometers. Guinea to Cairo, or not Cairo, Guinea to Chad is 8,000. Going from Egypt to Madagascar, we'll make it 15,000 kilometers. And let's see, Chad to Zambia, make it 9,000. And Chad to Madagascar, make it 11,000. And Egypt to Zambia is going to be 14,000. Is that all of them? No, one more. And Zambia to Madagascar, 5,000. Cool? Everybody got their numbers in there? Anybody still need a number? We good? We good? All right. So now what I'm going to do is I'm actually going to create your homework. So go ahead and flip your page over. And we're going to create the homework. You will notice if you read the instructions, it says give the distance and displacement of your chosen paths. Be sure to include direction when needed as a cardinal direction. The cardinal directions you can use would be north, south, east, west, or northeast, southeast, northwest, or southwest. As you are looking at them, we will start, let's see, the letters that I have. I have a G, a Z, an E, C, and an M. All right, the first one that we are going to do is we are going to go from M to E to Z. M to E to Z, and I will put these all on the next slide just in case you need them. The second one, we are going to go from G to C to Z to G. Okay? And I'll, like I said, I'll write them on the next slide. Number 3, we are going to go from C to M to E to G and to M. The third one, sorry, the fourth one. The fourth one, we are going to go to E to Z, because it's easy, to C, to E, to M, and then what one haven't I used? To G. And your last one will go from, let's see, what did I not start with yet? A Z. All right, so we'll start out with Z, and we'll go to C, to G, to C, to M, to E, to G. That'll work. All right, so you have your 5. You'll notice that I just increased it by 1 each time, just to not to make it more challenging, but just to make sure that you guys can still do your addition of distances. This should be a very easy homework assignment. The only work that I need to see would naturally be writing out your different distances so that I can visually see that you actually had them there. You know what I mean? So I know your calculator can do the work, but I want to at least see the distances you wrote, just in case you wrote the wrong number, and that way I don't have to take all the points off. Okay? So just to remind you again, number 1, MEZ. Number 2, GC, ZG. Number 3, CM, EGM. Number 4, EZ, CE, MG. And the last one, number 5, ZCGC, MEG. Okay? So you guys can work on your homework now. Gives you a half an hour. I mean, that's plenty of time to be able to do that. You should be able to finish up, and then we'll get started with speed, velocity, acceleration tomorrow.